So this talk is reactive reality, which is a sort of funny naming React and virtual reality. And let's say something about myself. Well, I'm a software engineer, like languages, compilers, working in the V8 team in Google, working in the Mono team in Novell, so working on JIT compilers for a lot of years. Started hating JavaScript with a passion. I just didn't want to look at that ever. And now I'm likely a full-stack developer, probably. I could be defined a full-stack developer. So first of all, adjust your expectations from this talk. I am not a UI or UX designer, which means I'm not going to show you ways to interact in a 3D world in fancy ways or things like that. This is not my job. I'm not able to do that. What I'll show you is a way to build a UI that is usable in a 3D world. So how to technically do it. Then whether it's fancy or not, or the UX, is up to you or the UX designer, I don't care. But how to technically do it, that's a different issue. And especially, how to technically do it in a solid way. So in a way that is manageable, so that you can actually do it and work on it and maintain it. So this was my goal, essentially, with this. And the point is, why? Why am I here doing this talk? And well, of course, virtual reality is all the rage. Virtual reality is sexy at this point. Everybody's talking about that. But this is just not fiction. This thing is starting from a real need. And the company where I work is called Hyperfair. And we do virtual trade shows on the web. You picture a fair, a trade show. We put it on the web in 3D. And also virtual showrooms. But actually seeing that should be easier. So let's see if I can do it in one hand. Yes. OK. So this thing is essentially our product. It is what we do. And we can go around. What you see on the side is the bunch of containers that are running in a Docker Compose, because this is running on this machine, actually. And you can go around. And as you can see, you actually have a UI in this thing. So you can chat with people. What is this demo effect? OK. You have a bag of things. You can have a map. You can interact with the map. You can go around. And when you go around on teleport, you go to other places. This is a virtual trade show. Unfortunately, I don't have the full assets on my machine, so you are not going to see all the textures of the posters on the pavilions. This looks a lot blank. And you're not going to see other avatars, because in this world you actually have other avatars going around, you can interact with them. So it's like a virtual trade shows online. So this is what we do, okay? Nothing fancy really, it's an application, you know, a web application. Okay. I'm still not used to, OK, now I can do it with my left hand. So now that you have seen this, you see that this thing, this core product, is in 3D, and it has a UI. And the point is that now we are transitioning this thing to virtual reality, proper virtual reality. I mean, Oculus, Cardboard, Daydream, those things that are so nice these days. And the point is that we want our user interface in VR, because otherwise, how can we use this thing? And the technology that we are using for this, well, we are based on Unity 3D, because we started this in 2011. In 2011, there was no other game in town. You had to use Unity 3D to do this thing on the web with a plugin. Now, we're still using Unity 3D, compiling the Unity 3D thingy into WebGL, which is something that Unity supports. So our UI is also done in Unity 3D, because that's the thing that we must do. But my point is, what if we wanted to use proper web technologies? Because using Unity 3D with WebGL, well, let's say is not the best developer experience you can imagine. So I was really thinking, and what if we can just strip Unity and build it properly on the web? What would I do if I had to do that? And at this point, I would say I have a dream, you know, a vision of a world where developers can build UIs in 3D, on the web, of course, in virtual reality worlds, and using the same technologies and tools they use normally. So the point is, we are still building user interfaces. If I'm used to build user interfaces with a particular framework or toolset, why should I relearn everything just because I'm going VR? And the problem here is the 10-90 rule, which is every nice project like this is 10% inspiration and 90% perspiration. And at this point, I'm sorry for you because the inspirational part is over. This is the great idea. And at this point, it's all about doing the dirty job. That's it. So let's build this UI. And let's see what we must do to build this UI, because on the web, UI means DOM. This is the way it works. Usually with a framework on top, of course, at this point. If it is even just a minimal complexity, you just want something on top of that. You're not going to manipulate it by, even just jQuery, but whatever. And virtual reality means WebGL. Again, usually with a framework on top, either 3JS or Babylon, but I don't think anybody is going to write raw WebGL calls one by one. And then, could I have, please, DOM over WebGL? Because that would be the solution. And I say, no, life is hard on us. This is not going to happen. This is sad. So one way to do this would be to use CSS 3D transforms. So the idea is, okay, I've got something in 3D, which is a canvas, and I have something which is the DOM, so let's say a div, which contains then my UI and everything, and I want to put this div onto the canvas in 3D. So I could say, okay, I have this div, and I use CSS 3D transforms to actually put it there, but they are not natural. And mostly the problem is they don't integrate with the Z buffer on WebGL. So which means that if there would be something in the 3D world that had to cover that div, it's not going to cover it. Because this div is not inside the 3D canvas. It's over the 3D canvas. And there is no concept of depth there. And there's even a worse problem. It is so out of the WebGL canvas that suppose that you want to go really in virtual reality with stereo rendering. So in stereo rendering, you are rendering your 3D scene twice, one for one eye and the other for the other eye. Now you've got this div with your UI. In which eye do you want to see your UI? Because it's one div. And so this is just not going to work. The only way to make it work would be to actually replicate the div, double that. Well, in theory, you could do it probably with React. You just render it 2 times. But it's such an ugly hack that I wouldn't do it, because then you would need to position the div in 3D with CSS 3D transforms in a perspectively corrected way for your eyes. I think, forget about it. This is not the solution. So, can I have DOM rendered inside the canvas? Because outside doesn't work. Let's put it inside. Well, the problem is, actually, there should be a way to do that. It's in SVG, but it's almost a joke. So if you build an SVG fragment, and inside the SVG you write the full string of the HTML that you want, it's actually going to render that. Problem is, if you want to change even one single element, you actually have to recreate the whole string and make it reparse by SVG. So this just cannot work. There are other problems, bigger one. The course gets in the way. Why does it get in the way? Because the security implications are really non-trivial. Suppose that in some way you can actually do it. This would mean that from your DOM, you would have access to something that has been rendered by other DOM elements. Now picture this, you've got the page with an advertisement. Ideally, the advertisement should not access the page. And usually you've got your silos of course and everything, so the browser is able to do that. But if you take everything and you splatter that as pixels onto a canvas, then in principle, the code inside an inner element could access the pixels rendered by the outer element. So it's like if you gave full screen reading powers to every piece of JavaScript inside your page. And this is a security nightmare. And this is essentially one of the reasons why this will happen, but not now. People are talking about that. They want it to happen. But as soon as you actually do it, you have this problem. So this thing would be nice, but we don't have it now. I mean, eventually, I hope the web will go that way, because everybody probably wants it. We just want to have the DOM inside a 3D world. But not now. Well, I say I don't give up. I mean, I want to do this. Other options? Well, at this point, we can more or less sadly give up the DOM. So there's just no way to put the DOM there. So let's say, okay, let's do something else. We should render the UI directly in the WebGL Canvas. And so the idea is, okay, we render the UI in 3D, but the WebGL Canvas is in 3D mode. But usually, what we want is a UI in 2D. And believe me, you really do want that. Because it's all fancy. We are going virtual world, everything is three-dimensional. But think about my use case. I want to show a business card. The business card is a piece of my UI. And it's got a picture of writing, another piece of writing, and they need to lay them out. It's 2D. It's flat. I want to put it inside the 3D world. But in the end, the kind of metaphor I'm going to use with my users is still the old flat thing with things written and laid out, which I usually do with DOM and CSS, with a framework on top. So I really want this. Eventually, I'll also do pure 3D things, with things floating in space. But I'll always have a need for this, because we just use them as human beings. It's just in the nature of what we do. So the idea is we can render the UI in a separated 2D canvas. So this canvas is flat. I can do 2D rendering inside it. And then use this 2D canvas as a texture inside the 3D canvas. You get a picture? So you've got a 3D world, three-dimensional canvas with a solid object there, and a texture is a picture that is painted onto the object. So if I use a 2D canvas and use that as a picture painted onto the object, then this is going to work. It's going to happen in the 3D world. Then, how do I render the UI in a canvas? Which framework I'm going to pick to do that? Probably one that we are used to. And I would say let's pick React. Why React? Well, it's really easy to separate the logic from the view code. And there's another thing. React is essentially DOM independent. So the fact is that React defines the view as a pure function of the props and the state. So whatever is your model. And this view is a pure function. The fact that these pure functions modifies the DOM is incidental. It could be a React native that modifies controls on a smartphone, or it could be React SVG that modifies graphical things in a vector graphics, or React whatever experiment a lot of people are doing, or React onto a 2D canvas. And now let's pick a sample application to actually do this thing, because I want to make something real, concrete. And the application is the ubiquitous ToDoList a bit simplified. So we'll see a ToDoList done like this. The implementation, well, for the implementation, I decided to build the logic in the Redux style, but just Redux style, because I wanted to reuse the logic of this thing, both in 2D and in 3D, and show it at the same time. And let's see how this logic looks like. And this logic is something like this. So essentially what I want is a bunch of actions that are add the current to-do, toggle the one to-do, remove the to-dos that are done, set the text that I'm writing, append text, and so on. And each action is a function. So I have a function build state that, given the next ID for the to-dos, the text in the text box, the list of to-dos and the amount of scrolling now, builds me a new object with this. The initial state is this, so no to-dos, no scroll, and so on. And then I have a function that builds me a new to-do. And then I can just add current means if there's no text, I just return the current state. Otherwise, I essentially return a new state with the to-dos inside, and so on. So toggle is the to-do. They're very simple functions. You see, it's very small. And this is very simple to test because it's Redux style. I didn't want to pull Redux as a dependency, something so small and simple, it seemed overkill. I just have this bunch of functions that are essentially my reducers, and I can invoke them. It's simple, it works. This is the implementation with normal React. And essentially, you have the render that builds a div with a panel heading, which has the input, and then another div which has all the to-dos as to-do elements, and in the end, a big button that says remove done, and dispatches the remove done action. So it's just usual stuff. And if you see it, it's this. You can add to-dos, and you can manipulate them, toggle them, remove them. It's just, you know, a very, very simple example of to-do using that logic, using React. And this is just to say, okay, we can have this thing done in the normal way. Then back to the canvas. And we need to draw that thing onto a 2D canvas. So what we want is a canvas drawing framework with React bindings. And the problem now is JavaScript fatigue. There are too many frameworks, as usual. And choice is good, but also hard. Mind you, I'm not really complaining. It's always better having a lot of choice than starting from scratch. The problem is you need to take your time to evaluate all the components, the framework, and so on, because the problem is that if you pick the wrong one, it's a mess. The top choices for me were, I actually like the idea of using React Canvas. That was probably the perfect choice for this. Problem is, the project is abandoned. It supports an older version of React. And doing the porting is non-trivial. There is an issue opened. They say they're not going to do it, and it's non-trivial. So I said, okay, nice. But since it's not maintained that way, and I wasn't able to actually do the porting in just in a few days, I said, okay, let's forget about it. Then there is Pixie. Pixie is a wonderful library that writes to the canvas. It has React bindings. It's very, very complex, complete. It's a lot of things. Then there is also Conva.js, another library that does the same thing. And in the end, as I said, pick your poison wisely, because you'll really live with it longer than you think. If you pick one of those things, it's very hard then to go in reverse and pick another one. You're going to waste a lot of time. I picked Conva. Why Conva? Just because the React wrapper is really, really simple. So since I had to tinker a lot with the React wrapper of Conva was a single file with a lot of simple metaprogramming, so that there was something like a template for components that you could use for every component. So it was understandable. I said, okay, this thing I can manage. And I also did another thing. I added CSS layout on top of that, because one of the things that I was saying, okay, I want to do a UI. Doing a UI means laying things out into this 2D space. And nobody wants to do that with absolute positioning. And you know, this is not going to scale when the complexity of the application scales. So I wanted to have something similar to CSS. And I took an implementation of CSS flow, in the sense the flow packing, done by Facebook. Sorry, Flexpack. And it's called CSS Layout, and it's in JavaScript. Essentially, it's a library that you give a tree of things to that, with some properties that are the dimensions and so on, top, bottom, width, whatever. And it does all the computation of the CSS packing algorithm. And then you can use those results in your rendering. And I also did a pull request to the Conva React binding for this. So it works. The guy liked that, but say, okay, I have to evaluate if it really fits, of course, because the code is not so simple. And what happened when I did it was essentially this. So this is again the to-do list, and you see that in the canvas there are things that actually appear. There is some kind of a layout there, and if I click these things, I can actually interact with them. Well, with the mouse it's simpler. And if I click here, it works. So it's something that is sort of working. The nice thing about this is that the code is really, really nice. Because if you look at it, the to-do element has a render function that does a group with 3 pieces of text. One is the text of the to-do, the other is either done or to-do, and the other is toggle. And this toggle has the callback for the click. And then the to-do canvas view is a group with the text, which is the text from the state, so the thing that I am writing. And then a group which has just the list of to-do elements. And then another text which is remove done, which has then the callback. So it's insanely simple. This is the thing that I actually would like to have and to work with. Now, I'm getting lost in the slides. Now the devil is in the details. So I did this, I was really happy. And then there was issues. And the issues were essentially that CSS layout is not enough. The problem is that it's enough if you want to do something like that. Then if you want to have a real curated appearance, you start needing to render on the canvas rectangles to do the background with rounded corners, the proper color, eventually gradients, and other things. And then I realized that, oh gosh, I have no primitive for this. In the DOM, you've got the primitive. You just have a div, and you say, this is the background, this is the border, and so on. On the canvas, I didn't have them. And so I needed to draw superimposed elements, like a rectangle, and on top of that, the text. And the rectangle need to have a certain style, like color, corners, and so on. And with that CSS layout model, I couldn't have superimposed elements, because they are of another CSS packing algorithm, totally different. So essentially, what I had to do was to hack into this binding that I did to make so that I could choose if I wanted to use the CSS layout or if I wanted to use an absolute layout. But absolute layout about what? What are the dimensions? Where do I put it? And then I needed to propagate the dimensions of the parent onto the children. Because if a child needs to grow, I mean, it's canvas. In the end, the primitive is absolute. I need to tell it exact dimensions. So I had to add code to propagate dimensions of parents onto children and to select which kind of layout algorithm to use. And mixing these layouts became really cumbersome. And CSS layout does always not do what you think because it's CSS, you know, so sometimes it's surprising. And okay, this is just about layout. What happened essentially was that this code, which was the old one, became, where is this? Where is it? Became this code. And essentially, this component, you see how huge this is. Okay, this component is panel row. So it's simply an horizontal thing which is up inside the panel and actually has a background. And you see the number of props that are all something like scale, width, height, fill, stroke, overfill, so all these things. And the rendering does a lot of things with all these properties. And essentially, what it's doing in the end is a group which has a rectangle, which is the background, with the events and so on and so on. And on top of that, another group with the children. So this is messy. Now, once you have this, the code below is not that bad. Because, for instance, in the panel footer, you essentially say, OK, panel row, on click, this is the field, these are the children, and it's sort of working. And so the panel body, again, has a render that is almost acceptable. Now, where was it? OK. This is essentially the to-do element. You see, it's a row with a group, with this text, this other text, which is essentially the icon for the button. So this is becoming manageable. But this is manageable at that other cost of complexity. So it's not so, it's worse than what I was hoping. Then there is the problem of event filtering and also keyboard events. Canva doesn't handle keyboard events at all because there's no concept of focus inside the canvas. So when you use the keyboard and write things in the DOM, usually you have an element that has a focus and gets the keyboard events. But here this is a canvas. I couldn't even listen to keyboard events. So I had to implement a trick. Essentially, when the canvas should have the focus, I actually add a key event handler to the outer DOM element, get those events, and then inject them into my actions that are on the canvas. Works, work around, OK. And so after doing this, the result is this. Here I have the 2D canvas, and I can write, and the events are actually captured by the canvas, and I can interact with it on the canvas. So this is starting to look something sort of reasonable. I mean, it's usable. And the funny thing is that they are mirrored, literally. So I can do one here, and 2, 3, 4 here, another here. I can move them, they move together. I can delete a bunch, and they work. So because they are sharing the logic and the model, they are just different views. And since in React the view is functional, this is not a problem. So, OK, we did it. And now we have a 2D UI inside a canvas. We still want to show it in 3D. That was the goal. So we must have a 3D scene. And 3D scene means I picked Babylon as a 3D framework. And essentially what I did was, I'm not going to show you the code of Babylon because it's long, it's messy. But essentially what I did, please, OK, is build a 3D world with 3D objects. And unfortunately, the lighting is very bad here. But you get the idea. And I can interact with it. You see that I'm marking them here. I can even write here. So it's just the same view. Events are flowing. Now, and then more issues. Because to do this, mapping events is extra tricky. Essentially, what I had to do to map the events was, so I have mouse events on the outer canvas. I get the 2D coordinates of the mouse events. Then I use a Babylon facility to map these 2D coordinates using the camera onto a ray. And this ray is cast into the 3D world. This ray intersects this 3D object at a particular point. Then I get the point, okay. And when I get this point, I can feed it back into Babylon again to get the coordinates of this point inside the texture in 2D. Now that I have them, I have essentially the coordinates of the point inside the 2D canvas. So I can create a synthetic mouse event and inject that into the 2D canvas system so that it finds the correct conva component. And then that conva component is going to fire the event that is going to the React event handler that is going to my event handler. Well, okay, it works, as you have seen. But, okay, the nice thing is that when you do it and it works, then it works. So then you can use events. Then, I wasn't in the slides. Then the fact that Babylon events and set states were fighting each other. Essentially, if I invoked set state inside an event handler in Babylon, I had crashes. What I had to do was to do the React set state asynchronously inside a request animation frame. So the idea is I have the event, I know I need to do something. I'm going to do this thing at the next request animation frame. And then everything works because then the state changes, I've got the re-render, and I want to show the re-render at the next frame anyway, so this is not so bad. But to actually debug this and get the solution has not been so pleasant. And did I say mapping events was tricky. So, okay, it works. And about VR? What about VR? And the nice thing is that for VR, it's not difficult. At this point, the only thing I need to do is to change the camera. So this is the code for the camera. And this is actually creating a virtual reality camera, which does the stereo rendering. This is okay, because I just restarted the thing. So here, if Webpack did its magic, what we have is a stereo rendering. And this is the same code as before. So this is not hard at all in the end. So future ideas would be real 3D UIs and a unified binding of 2D and 3D. So right now I only worked in 2D essentially. I used Babylon the old way. The nice thing would be to have a React binding for both the 3D part and the 2D part seamlessly, so that I can have a view that generates 3D objects and 2D surfaces on so this would be the proper way. This has been an experiment, it works, it's fine, but to actually be able to use it in a real product, I would probably redo it with a proper binding like that. And there would be things I need to fix in Babylon. The clipping in 2D, the layout engine needs to be retaught because I discovered that, okay, I made it work, but it was cumbersome. And the way that you map textures onto the mesh, there are technical issues that should be done. But that said, the takeaway is that the proof of concept works. It's not production ready, but it's there. And with current framework, it's a bit more cumbersome than what I wanted. So as I said, 10% inspiration, 90% perspiration, that's it. But the point is, it can be made beautiful from the developer point of view, because if you get the mapping right, then you can really have your view code with simple React elements that produce your view. You've seen it done. In my first try with the pure CSS thing, it was beautiful. Then it was the wrong usage of CSS. I didn't know. I realized it afterwards. This is what experiments are for. I did it, and I think I'm even on time.